Okay, so from my previous video, I think I said that this C was top and bottom. I meant for this problem, it's left, right, rightmost or leftmost. Okay, so this Y distance C just depends on if this Y is horizontal or vertical. So if this distance axis is horizontal, then it's the rightmost and the leftmost. If it's this distance axis is vertical, then it's the top and the bottom. Okay. So let's move on to sample problem 4.8. Okay? The largest allowable stresses for the cast iron link are 30 megapascals in tension and 120 megapascals in compression. Determine stress at point A and B. Determine the largest force P which can be applied to the link. Okay, so yeah, again, the problem will tell you we want the section AB. So we're going to take the cut at AB. And the cross section is a T-beam. So we're sample problem 4.2 already found the moment of inertia and Y bar. So if you want to review how to find moment of inertia, you can look at sample problem 4.2 on page 236. Okay, but sample problem 4.2 gave us Y bar is 38 millimeters from the bottom. Okay, so in this section AB, this is an eccentric loading because the load does not go through the centroid of the section. So these are all the same steps. You find what P is, you find the moment. Okay, so we're going to take a cut at AB. Force is going to your right. It's a compressive force. Here, the external force is a compressive force to your right. So the internal one is to your left. Some of the forces, some of the moments about C, it's a counterclockwise moment. So the moment here is a clockwise moment. And the moment is force times distance. Force times this moment arm right here. From the centroid to the force. Okay. So, can you tell me, is this the top or the bottom? Is the top in tension or compression? And the bottom, is it in tension or compression? The bottom is in compression, the top is in tension. And how do we find D? Okay, let's find D. The moment arm for the load. Okay, turn to slide 21. So from sample problem 4.2, they told us Y bar is 0.038. Okay, so from the bottom to the centroid, it's 0.038. The load is 10 millimeters from the bottom. So this moment arm here, D, is 0.038 minus 10. 0.038 meters minus 0.01 meters. Okay, so D is 0.038 meters minus 0.01 meters equals to 0.028 meters is D. So the moment here is load times 0.028 meters. So moment is 0.028 P. Okay, so that's what it says on slide 21. Okay, the top is in tension, bottom is in compression. Now let's turn to slide 22. Again, we need to draw the stress caused by the eccentric load at adding the stress caused by the moment will give us the eccentric loading. Okay, so here it's a compressive stress to your left and a clockwise moment. Okay, so compressive stress to your left and a clockwise moment. Okay, so let's look at the eccentric loading here. So we know that that's force over area. Area is the area of this T cross section. So that's 3 times 10 to the negative 3. Area is 3 times 10 to the negative 3. So P equals stress over area. So, oops, sorry. Stress equals to P over area. Okay, so stress equals to P over 3 times 10 to the negative 3, which equals to 333 P. So that's stress for the eccentric load. And that's going to be negative because it's compression. It's compressive force. Okay, let's turn to slide 23. So stress from the moment, the top area will be in tension, the bottom part here will be in compression. So let's do the top part. It's MC over I. The top is point A, the bottom is point B. Okay, and point B down here will be MCB over I. So CA is from the centroid to the top, CB is from the centroid to the bottom. And this top area is in tension, the bottom area is in compression. Okay. So plug in all the numbers. We have M is 0.028 P times CA. So from the centroid to the top is 0.022 meters over I. I is given in the sample problem 4.2. 868 times 10 to the negative 9. M is same 0.028 P times from the centroid centroid to the bottom. 0.038 over 868 times 10 to the negative 9. So this will give you 710 P tension, so positive. This will give you 1,226 P compression, negative. Okay. Now let's turn to slide 24. So we're going to add the two. The eccentric load plus the stress from the moment will give you the eccentric loading. So yeah, it's just adding both of the numbers. Okay. So we get that. So slide 24, we get that the top at point A is positive 377 P, and the bottom here is negative 1,559 P. Okay. Now the different part for this problem is slide 25. So we know that allowable load for tension is, so max for tension is 30 megapascals, max for compression is 120 megapascals. So we set that equal, so the tension we set it equal to 375 P, compression we set it to negative 1,559 P. Critical load for tension is 79.6 kilonewton. Critical load for compression is 77.0 kilonewtons. So we picked the smaller one right there. So when load of 77 kilonewton is applied, allowable stresses for compression and tension will not be exceeded. Okay, so these two stresses will not be exceeded if we have the lower load. Okay, so the final answer is 77 kilonewtons. Now last bit, problem 4.101. Knowing the magnitude of horizontal force P is 8 kilonewtons, determine the stress at point A and point B. So we want to take a cut at point A and B, and there's a load here, and it's an eccentric load. So I'm going to take a cut here. Some of the forces in the x direction equals 0. This is a compressive stress. So this is to your left. So you're going to have a compressive stress to your right. Okay? You're taking a cut here. This is the member right here. Okay? So the eccentric load is going to your right. It's a compressive load, so it's going to be a negative P over A. And this, when you take the sum of the moments about point C equals to 0, this force is going to be a clockwise motion, so this is going to be a counterclockwise motion here. So that means that the bottom is going to be in compression. The top is tensile. Okay? Top is tensile. Bottom is compressive. Now, you always need to find moment. So moment is load times distance. What is this distance here? It's from the centroid of the section to where the moment is, the moment arm. So the centroid to where the load is. So this distance is 0.045 meters. You're going to minus this distance here because you want it from the centroid to the load. This total distance 0.024, so this small distance is going to be 0.012 meters. Okay, so D is 0.045 meters minus 0.012 meters, and that will give you D. Okay, so moment is 8 times 0.045 meters minus 0.012 meters, parentheses. All right, so that's the end of the lecture. Let's turn to the last slide. So quiz 3 will be Thursday on chapter 4.1 to 4.7 and what we learned today. It's going to be open book, and you need to time yourself to have a 1.5 hour time limit. Homework due Thursday is 4.99 and 4.102 and 4.105. Please go to the discussions tab and write a comment on today's lecture material for participation credit by 5 p.m. Tuesday, March 24th. And please help each other and answer each other's questions. Okay, that's it. Hope you have a great day. God bless.